We've now defined the power series all by itself can be a function, and the function is a fairly simple function, but it is this reciprocal function here, 1 over 1 minus x. And it's important to note also that it's only valid when x allows this series to converge, or when x is between -1 and 1. If it's beyond -1 and 1, when we add up this series, it's just going to, in fact, grow and grow and grow and get bigger and bigger and bigger, so it will never converge. So at this point, what we're going to do is we're going to start with this base polynomial series, or this base function. So we have our original function, and we'll just call that maybe g. So we're just going to say that g of x is going to be that function. And we're going to come up with another function we'll just call f of x. When we do some kind of substitution, we should be able to get 1 plus x squared, or sorry, x cubed. So first things first, we're going to maybe do our substitution here. So we're going to say that to get the function f of x, which is 1 over 1 plus x cubed, there must be some substitution into the g function that gets us there, okay? And so we end up with our starting point g, and I'm just going to draw, some of you guys may have figured this out already, you're just going to do a substitution, but I'm going to substitute that, some expression into there, which I'll just call a, and plugging in for a, that's going to convert 1 over 1 minus into a 1 over 1 plus x cubed. So we just have to figure out what that is. Now, we can just kind of see that if I replace the brackets with negative x cubed, I'm going to get 1 plus x cubed. So then my f of x function is going to be g of negative x cubed. And when I do that, I end up with 1 over 1 minus x cubed, sorry, negative x cubed, which then is going to be that function. Well, this function can be expressed also as the power series. So it can be expressed as 1 plus x squared plus x cubed plus dot, 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 dot. And to make the polynomial part of this, the series function, the infinite series function using x, I'm just going to plug the negative x into here, and oops, negative x cubed, and I can do this infinitely for however many terms I want, depending on the accuracy that I desire. So this 1 over 1 plus x cubed comes from our root function g of x, and then we just have to figure out what a we need to substitute in to generate the function that we're looking for. Once we do that, we can express it either in its g form, g of x form, or in its series form. Okay, the other part of this is it only works when it converges. So when we want to check for values of x with this power series works, it only works for values between -1, or sorry, when that x, the inside part of that is between -1 and 1. So I can set this up as negative x cubed must be between 1 and -1. Okay, so that means that x will converge when I cube root, do the negative and cube root both sides. It's going to converge between 1 and -1. Okay, so when we graph this function, we'll see that it's converging between -1 and 1. For example 4, we need to start with our base function again. So again, I'm just going to define our g function as the starting function, which is our infinite geometric series. And we need to do some kind of substitution on the x to be able to make that work. In this case here, we're not going to do an embedding function to do that. We just need to factor out the 2x. So if I want to express this function and be able to use that power series, 1 over 1 minus x, I'm just going to factor the 2x out, 2x, and then I'm going to end up with 1 over 1 minus x. Okay, so that's just going to be 2x times g of x. And there's nothing on the inside of g of x, so this is going to be equal to 2x on the outside. And I'm now going to express this with the series. The series for g of x is going to be 1 plus x squared plus x cubed plus dot, 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 dot. Okay, so there's my polynomial series that's going to express that 2x over 1 minus x. And if you want, you can combine that all together. We can just say that this is going to be 2x plus 2x squared plus 2x cubed plus 2x4 plus dot, 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 dot. Okay, and the values for x which the series converges is going to be valid for when this value here is between -1 and 1. Well, there's no kind of transformation on that, so we're just going to say it's valid for x's between -1 and 1. So this is essentially my domain.